Ladies and gentlemen, please welcome to the Swift 4 tutorial. And today we're going to start the episode 2. In this episode, we're going to cover two more fundamental areas in the Swift language. The first one that we're going to cover today is loops, and the second one is object-oriented programming. So just if you haven't watched the first episode, please go back to my channel and watch it. So if you haven't watched that, and this part is going to look a bit tricky. So let's start. So as usual, I'm going to open Xcode and then I'm going to open the playground. So let's delete everything. So let's start with loops. So basically, what is a loop? Loop is a way of executing a command repetitively. So let's do an example, so then it will make more sense. So first thing first, so I'm going to create a function. So if you have watched the episode 1, then you know how to create a function. And I'm going to say make t. Inside the function, I'm going to say by t. Boil water. Sorry. Once you boil the water, then you need to pour into a jar. Then you're gonna have to mix, or you can just put the tea into the water, boiled water. And last but not least, let's mix milk and sugar. So this is what you have to do to make a tea. So how we call the function? We can call it by simply typing the function name. So let's say make tea. If you click Ctrl S, so here you see it print out all the steps that you have to do. So let's say you want to make 5t. So what you're gonna do? You're gonna have to call it 5 times. 2, 3, 4, 5. You save it now. You can see now it's adding 5 t's. So let's add a separator here, so otherwise then it will make more sense. And we'll put dash 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 dash. Okay, so here you go. 1, 2, 3, 4, 5. The tea has been made 5 times. But isn't it cumbersome? And didn't we learn if we are to do coding, it's better not repeat the same line of code? So here we can use the loops. Let's see how to do that. So I'm going to delete all of these. So let's use a for loop and just make 5 t's. So what I'm going to do first, first I'm going to create a variable, number of t that we want to make is 5. Then I'm going to do a for loop. For, this is how you write the syntax for the for loop. I in 1, 2, number of t. Inside this function you can simply call make t. So now you can see 1, 2, 3, 4 and 5. 5t has been made. So what happened here? So let's look at it here. First we have created a function, then we have a variable with the integer number 5, that is number of t's that we're gonna make, and then here we have I. So what I is basically the index, the current t that you are making, so you can get the index. So let's just forget about it at this moment. And second thing is, what we're going to do is we're going to count from 1 to number of t. Number of t is actually 5. So instead of number of t, you can simply type 5 here, and the result will be same, you see. And if you put 6 here, it will make 6 t's. So I hope it's a bit understandable right now, because first we start with 1 and we call this function, and again we repeat the same. We are now 2 and we call the function, and so and so and so until we reach the number 5. We call the method make t. So what we ideally doing here is we are calling the make t function 5 times. So that for the for loop. And the another thing I'm going to touch is a while loop. So while loop is similar to the for loop. It's again going to run again and again while the condition is met. So let's see how to do a while loop. First, say I have a variable my number and it's equal to 0, and then I'm going to run a while loop. This is how we do the while loop. My number, if my number is, as long as my number is below 10, I'm going to run this loop. So let's say my number equal to my number. So what are we doing here? So once we come inside the loop, we're going to increase the value of my number by 1. So like what we are doing here is we are adding 1 to the variable my number and assigning it to the my number. So what is going to happen is, initially it was 0, so we're going to add 1. 0 plus 1 is 1, and we're going to assign the value 1 to the my number. And when the loop execute for the second time, it's going already the my number is currently 1, and we're going to add 1 to it. It's going to be 2, and we're going to assign the value my number to 2. So this while loop is going to run as long as this condition is met, and the condition here is my number should be less than 10. So we can just print it and check it. We can just print it, my number here. As you can see, it runs 10 times. The first time it comes inside, this value becomes 1, and it prints the value here as 1. And then second time it come inside, and now the value is 2, it prints it here as 2, and so and so and so until it reaches, finally it reaches number 10, and it comes to the loop and it says, okay, it's no longer 10, it's equal to 10. So if it is not less than 10, we can run it, but currently it's greater than 10, or it's currently equal to 10. So in that case the condition is not true, so it's going to exit from the loop. So this is how the loop functions. Another advantage or the usage that we can take out from the loops is traversing an array. So we looked at arrays in the previous lesson. So let's go through another example. Let's say I have an array here, and let's call it my friends, and it's a string array, which means we're going to store string values inside this array. We learned how to create array, etc., in the episode 1. So go and check back if you can't remember. Let's add a couple of names: Kenny, Kathy, David, Tom, Thomas. So we have 1, 2, 3, 4, 5 people, 5 friends. So what if you want to traverse through this array and get the values one by one, or print the values one by one? So we can simply do it with a for loop. So let's see how to do that with a for loop. We start with the keyword for, and they say friend in. Now we need to give the friends, my friends array. That's the name of the array. Now inside this loop we can directly access the element, that is friend. So what actually happens here is, you see the friends names are printed here one by one. What actually happens is, here the for loop is going to traverse through this array, and so when it runs for the first time, it's going to pick up the first element, and that element will be assigned to the variable friend, and when you print it, it will be printed in the debug area. So and so and so it will go and on print and print and print and print until it reaches the final friend's name, the Thomas. So I hope it makes a bit of sense on what is loop and how we can use it in our day-to-day programming activities. So in the future we're going to do some couple of sample labs, and that time you can actually use all this stuff that we have learned here, and at that time you can really see how all these concepts are really being used when we are developing a real-world application. So that's it for the loops. Let's get back into the most interesting and exciting area of any language, that is object-oriented programming. So before starting object-oriented programming, we need to talk a little about some of the concepts. So the couple of keywords that I'm going to use are going to be classes and objects. So what is a class? Class is actually a blueprint to represent real-world objects programmatically. And we can give attributes and methods for inside these each classes. For example, bird has 2 wings, 2 legs, and those are attributes, and it can fly, and then that is a method. So let's do some example and see how we can map real world objects in programming. Let's create a class. Let's name it soldier. So I'm going to define a class by typing the keyword class, and I'm going to say soldier. That's it. So now we have a blueprint for the soldier, but it's kind of empty and we don't have any attributes in it. So let's add some attributes. Age. A soldier is a human, so he must be having an age. Let's say he is 23 years old, and he must have a uniform. So let's check whether he has a uniform. So I'll say has a uniform, and it can be either true or false. In this case, let's give it a value true. So this soldier has 2 attributes. One is his age and whether he has a uniform or not. Now we're going to create, so this is a class which is a blueprint, and now we are going to create an object out of it. So let's see how to create an object. So I'll increase the font size so you can easily see it in the YouTube video, creating the object. So let's create the object list, my soldier, and I'll simply say soldier. That's it. Now we have an object. So in Java we need to use the keyword new when we are creating an object. Here we don't have to use any of those things. Similar to Kotlin, if you have used Kotlin, it's same as this. And I recently have used Kotlin, and I actually made a video about it also. And if you just go and check it out, it's very much similar to Swift. So it's really awesome because you can learn Swift and you can use almost the same concepts in Kotlin as well. That's two birds with one stone. So we have created an object, my soldier. So how do we access the attributes? This is how we do it. So let's say, so I'm going to print out my soldier dot age. Simple as that. You see in the bottom it prints out 23. So we need to know whether he has a uniform or not. So let's say my soldier has uniform. True, he has a uniform. Now you can manipulate these values. Manipulate these values. Say my soldier, he is 24 years old. He is no longer 23 years old. Let's print it again. My soldier dot age. Now you see it prints 24. So this is how you actually create objects and you manipulate the attributes. So similar to this age, you can actually go ahead and change the has uniform value as well. You can set it as false or anything you want. To be on the safe side, I'll just explicitly mention the type. You know, we humans are good at making errors. So let's make sure these values are defined, so I won't be able to assign any other values here. You can see, so that's how we create object and then we manipulate values, and this is how we access the values as well. The next thing is what can a soldier do? He can actually shoot the enemy. So let's create a function. So that is a method. So actually methods are function. When they are associated with a method, with a class, they are called methods. So methods are actually a function. When they are associated with a class, they are called a method. So let's create a function. Say shoot enemy. So let's say print shooting enemies, shooting enemy targets. So let's how we do that, access that. Here we can simply say my soldier dot shoot enemy. When you are accessing attributes or variables, we simply type the variable name, but when you're accessing a method or function, you put two brackets like this at the end. So that means it's a method or a function. So here in the bottom you can see shooting enemy targets. It's getting printed. Awesome, isn't it? So let's move on to the next step. Now we have soldier and we have created object and we manipulated values and we have a supporting method as well. Now the problem is when we are creating these objects, it always has a default value. So what if I want some other values when I create a soldier? In real world example, soldiers are not always 23 years old when they are joining the army. So how we can do that? That can be achieved by declaring a constructor. If you're coming from other WP language background, you know what is a constructor. Constructor is just another method or a function that supports the creation of objects. Let's see how it can be done here. So what I'm going to do is I'm going to get rid of all these values, and Xcode is going to go crazy and it's going to throw errors. It doesn't matter. So I'm going to type init. So when you type the keyword init, that's going to be constructor. Just like any other method function, you put the brackets, and now inside it I'm going to say soldier's age, soldier age, which is int value. Next thing, has soldier has uniform, soldier has uniform, which is a boolean value, inside it, I'm going to say self.age is equal to soldier age. Like self.has uniform is equal to soldier has uniform. So what is self here? Self here is actually referring to the current class that we are working with. So in this case, it's the soldier class. So self.age means it's referring to the age variable of the soldier class. Simple as that. Remember like that, you won't get confused in the future. So still Xcode is so mad and is throwing errors because we can no longer use this way to create objects. So let's see what I mean by that. So let's say soldiers, and if I type the bracket, you see Xcode is smart enough to give me all the values that is necessary to create an object. So I'm going to say my soldier's age is 34, very old soldier, and he has a uniform. True, yes, he has a uniform. Now you see first it's printing as a 34, true, and then we are manipulating the value. Now we have reduced the soldier's value back to 24, and when we call the method inside the soldier class as a shoot enemy, and it's printing shooting enemy targets. So this is how you define a constructor. Constructors are very handy, will come in very handy when you're doing a very large scale projects and when you're dealing with very complicated objects, which is obviously you're going to do in the future. So that's it for the constructors. Now let's dive into a next topic on OOP, or the object oriented programming, that is inheritance. So what is inheritance? Just take the real world example. We inherit from our parents. I have inherited my father's nose. I have inherited my mother's eyes. So and so. So similar to that, since we are conceptually representing real world objects in this class, these classes can inherit from one class to another class. Let's do another example. The soldier is actually a human. So I'm going to create another class called human. And all humans have, so I made a mistake. It's a class, so there is no this bracket, only the curly braces. Okay, so let's give it a parameter. Human has a number of eyes. Human has 2 eyes, which is type of a integer. Now my question is, I want to make sure that the soldier inherits from human, because obviously all soldiers are humans, unless or otherwise some cyborg stuff is created in the future or in near future, I don't know. At this moment, soldier is a human. So how do we inherit the attribute of number of eyes into soldier? It's simple. We put a colon and type human. That's it. So I'll come back here and I'll say print my soldier dot number of eyes. You see printed as 2. So what really happened here is I have a class called human which has an attribute number of eyes, and I'm inheriting from that class human to the class soldier. So when an object of soldier is created, he's going to inherit all the attributes in the human class. So is it only attributes? Can we inherit methods? Yes, we can. So what? So let's say a human can walk. So let's say func walk. Let's say print human is walking. So can we call that function here? Can we? Let's try. My soldier dot fork. Yes, we can. You see, not just attributes, even the methods or functions can also be inherited when we are inheriting from a class. So in this case, this human is called superclass and this soldier is called subclass. As it's self-explanatory, right? The human is in the top hierarchy and we are inheriting it to the soldier. So here I have a problem. I have a little problem here, because isn't it nice if I say soldier is walking? Because human is walking is very generic. Even when a civilian is walking, that is also can be a human is walking. So how do we override that function? So this keyword, remember this keyword, override. So to override a function, you simply have to type the key override and then you type the name of the function, walk, that you need to override. So inside here I'm going to say a soldier is walking. Now you see it changed to a soldier is walking. Initially it was printing as human is walking. So this is how we override a function. So we override the function of a superclass in the subclass. So that is overriding. So what else can a soldier do? So he can run. So let's create a function. So with this example, we're going to look at method overloading. We just looked at overriding with this keyword override, and then we're going to look at another concept called overloading. So let's say func soldier run. We are giving a command, soldier run. Okay, and I'm going to say print soldier run. Soldier is running. So let's access it. My soldier run. But okay, it's getting printed here. Soldier is running. Awesome. But isn't it awesome if soldier is shooting while he is running? Let's see how to do that. The problem is I'm going to use the same function name, func soldier run. Sorry about all this stuff, but Xcode is going crazy. It's throwing errors. Don't worry. Let's say shooting, which is a old value. So what I'm going to do right now is inside it I'm going to say, so just remember the stuff we learned in episode 1, decision making or control flow. If shooting, which is a boolean value, is true, then we're going to say print soldier is running and shooting. Else I'll just copy and paste this stuff. Soldier is running. So still it says soldier is running. And next again try it. My soldier. Let's make some space. My soldier. Soldier run. You see there are two methods. Now when I type dot soldier run, there are two methods: soldier run with a parameter, soldier run without parameter. So this is called overloading. So here the functions are with the same name, but they have different method signature. One function has a variable or that has one accepting one variable called shooting. Other one is just empty. It's not accepting any input. So in this case, I'm going to say true. And see, soldier is running and shooting. So try it again with false. Soldier run, shooting, false. Okay, soldier is running. When we say don't shoot, he's not shooting. He's just running. So you can simply do a game in in a playground like this, a text-based game. Um, Here, when we come back here, I have a problem. The problem is, as I always says, you should not be repeating stuff. Here we are repeating the same line of code here and here. So how we can get rid of it? Simply call the function soldier run here. Isn't it cool? So this is how you reuse code in your code base when you do real world applications in the future. So that's it for method overloading. So we looked at overriding and overloading. Don't ever confuse it. Those are two different topics. So next thing we're gonna look at is convenience init. Again, another type of constructor. So we looked at how to create objects with default values and how to create objects without default values by passing custom parameters to the constructor. Since sometimes you should be able to create a object with default values, and sometimes you would be able to pass some parameters and create another object with some custom values. So you would like to do both with the same class. So how do we achieve that? For that, we're gonna use something called convenience init. So let's see how to do that. So I'm going to create a class which is a bird, and it has a number of legs which is going to be 2, and can fly, which is a type of a boolean, say 2. So by default we have two values. So if we create an object for a bird, it's obviously going to have the variables as number of legs 2 and can fly true. So what if we want to pass some custom parameters? First we're gonna create an initializer, and we're gonna get rid of it. Next thing, we're gonna type convenience init. Self.init. Basically we are calling the super method, not the super method, this init method. And what we're going to do is we're going to pass two parameters: number of legs of the bird, which is an integer, and can the bird fly, which is a boolean. Now after calling self.init, what I'm going to do is I'm going to say number of legs, or we can simply say self.number of legs is equal to number of legs of the bird. The self.can fly is equal to can the bird fly. So let's see how we can really achieve what I promised initially, that whether we can create an object with default values, and then we can supply some values and create a custom object as well. So see whether how to do that. So let's say let bird object 1, or we give it a real name, parrot, and say which is a bird. You see, I'm not supplying any values. I'm going to just print. Oh, it should be actually small letter. it's there's nothing wrong. Program won't crash, but it's a good practice that we always declare the or start the variable names or object names with small letters. So parrot dot number of legs. Oh, number of legs too. Awesome. So now I'm going to submit alien bird, and I'm going to submit custom values for the constructor. So let's say bird, put the bracket, and Xcode will suggest all this stuff for you. Number of legs, I don't know, this bird may have 10 legs. And whether it can fly, no, false. It will only run, false. So alien bird, I'm going to print it. Alien bird dot number of legs. You see, alien bird number of legs is 10. So it's simple as that. It's very easy, it's very straightforward. So if there is a requirement where you have to create an object with values, as well as you need to create objects with custom values, so those two scenarios can be addressed with this convenience in it. So that's for it. I'm going to delete this section, and I'm going to reuse my soldier stuff again. So the next thing I'm going to cover is protocol. So protocol oriented programming, or POP, is actually a vast area. So in the future I'll be doing another tutorial or another episode on protocol oriented programming, which is really interesting and an exciting way of programming in iOS or Swift. So let's say what is protocol and how we can implement it. So protocol is basically similar to interface in Java. If you're coming from a Java background, so protocol is pretty much similar to interface. So let's see how to define a protocol first. So we type the keyword protocol and we give it a name. Start with capital letter, which is a machine gun. So what can a machine gun does? But what can a machine gun do? Machine gun do? It can shoot. So here, this is how we define the function. See, we just define the function here. We don't implement it. So machine gun fire machine gun. See, I have just declared the method and I have not implemented it. So if I to implement this method, first I'll have to conform it to an object. Let's say soldier is inheriting from human, and to conform to a protocol, again we'll have to put this colon and type the protocol name. Since we have already inherited it from a class, we can say put a comma and say machine gun. Now again Xcode is going crazy and is saying, hey, you have not implemented that method. Okay, I'll implement it. So how do we implement it? It's simple. You just have to go and say, just implement this function, fire machine gun. See, you just type the function here, and you can say print soldier is firing the machine gun. So what if, so let's first run it and see my soldier dot fire machine gun. You see, soldier is firing the machine gun. So what's the advantage of this protocol? So basically, if you have conformed to a protocol, you must implement the method declared in the protocol. So it will again reduce human errors. Say for an example, you have a requirement where you need to implement a method as a mandatory stuff. So how do you do that? First, you create a protocol and you define the method inside that protocol. And when you conform to that protocol in a class, you must implement that method. Otherwise, the compiler is going to throw error and it's going to go crazy. So once you implement it, both your requirement is matched and the Xcode is happy and it will run the program happily. So that is about a protocol. So let's see how we can conform it to another class. So let's create a civilian class. Unfortunately, we deleted the class that we have created previously. Never mind. So I'm going to say civilian, and civilian is going to conform to machine gun. You see, both the inheritance and conforming to a protocol are done the same way. And if you have to conform to more than one protocol, you can put comma and do stuff. And the one thing that you need to remember is most of the programming languages, including Swift, doesn't support multiple inheritance, which means you cannot inherit from multiple classes. So for example, we say we have superclass called human and another superclass called monkey. A soldier cannot inherit from both human and monkey. Either he can inherit from human or he can inherit from monkey. So that is it. That's for your information. And let's see here, like we have conformed to machine gun. The civilian class, it's throwing in error, saying, what does it say? Does not conform to the protocol machine gun. So let's implement the function fire machine gun. It's very highly unlikely for a civilian to fire a machine gun, but for the sake of programming, let's do that. Print civilian is firing a machine gun. So pardon my spelling, I'm too lazy to correct it. So let's create an object now. Let civilian, okay, that's object. Let's print civilian dot fire a machine gun. Actually, we don't need to put it inside print because inside the method we are already printing. See, the civilian is firing a machine gun. That's it for the protocol. So I hope you learned a bit about protocols and overloading, overriding, classes, and inheritance, and all these buzzwords, especially constructor. Also, initially we looked at loops and how we can use it in a real world scenario. So that's it for this lesson. So we mostly have covered the basics of Swift language. So in the next episode, probably we can do a sample app, something as a small simple game that we can do and apply the stuff that we have learned so far in the episode 1 and episode 2. So that's it. I'll wind it up here. Thanks for visiting my channel and thanks for watching my tutorials. If you want any changes, if you have any suggestions, please comment it below. Thank you, and please subscribe and give it a thumbs up. Have a good day. Bye bye. Oh, by the way, today it's really exciting because Netflix has released Stranger Things season 2. If you are not watching, please go back and watch that. It's really worth it. Okay, gentlemen. Bye bye. Have a good day.